Oh, hi. It's Monaco.
Milks is behind the camera.
And there he is.
Yo, what up?
I am coming to you today from 3B03.
2. Oh, yeah, 3.
Or 2? Yeah, something like that. Our lab. Your lab, if you so choose to stay on pace. This lab is called Manipulating Reaction Rates. It's conformational chemistry. This is all feeling and working off of what collision theory tells us. It's a reaction taking place. We got to have effective collisions for a reaction to go. Your Pogel was about the home runs. This is about literally seeing a chemical reaction occur, and it's the bubbling of an antacid tablet reacting with acid. So this is happening in your tummy every time you take a Tums. We are going to speed up or slow down reactions by increasing or decreasing the number of effective collisions between the reactant particles. That's what this lab is about. Your purpose, I need you to investigate how we can change the rate of reaction, how quickly it completes, by changing things like temperature, particle size, and concentration. So you should, if you've been paying attention, already kind of have an idea how changing these parameters will change the rate of reaction.
Right, we've learned about 6 factors we could
And we're going to work
adjust.
with 3 of them today in this lab. The other 3, it's not as feasible or easy to do. And you still get the same idea, so. Procedure. There's actually 3 procedures you're going to do. So I need you to write what you have to do after I demonstrate them, step by step.
That's how you even get in the lab, is
Yeah,
to prove that you know what you're doing.
Checking to see. So the first procedure I need you to do, what you do is you're going to put bullets down on your list. This is not, I don't want to see this. If I see this, that means I know you weren't paying
going right
attention.
away. I'm moving away.
So the first thing I need you to do is get ready to do concentration variation. So I got concentration test beaker. I'm going to put it on my table. I got a whole antacid tablet. I got it ready to react. Now, I'm going to take 20 mils of my concentrated acid stock solution using the pipette. It means I got to measure this out twice. Okay, you got to do this 20 mils. Okay, I'm not going to do the whole thing for you because that's your job. So, once you've got 20 mils of the concentrated acid, you're going to add it into the beaker. You got 20 mils of acid in here. Toss your tablet in. Count, time, check it out, and see how long it takes for the reaction to stop bubbling. That's how you know the reaction has completed.
Okay, good.
I want to see a data chart. Concentration. High concentration versus time. How long it took. How many 1/1000s, 1 Mississippis, or seconds it took for that tablet to completely react with the 20 mils of the concentrated acid.
Sure. We might even have, if we're lucky, have a timer running for you guys on a smart board, so it'll make that a little easier.
So once this is reacted, you're going to have some sludge in here. Rinse it with water. It's neutralized, goes down the drain. You got a nice, fresh, empty beaker here. You got to do the second trial for the first procedure.
And what are we going to change?
The concentration of the acid. How do you think we're going to do that, Mr. Milks?
Well, I want to make it more concentrated to make it go faster, personally.
Can't do it. We can't make this any more concentrated. We got to make it more dilute.
Oh, okay. That'll work, though, right? So
By
this should
adding-
make the reaction what, then?
Well, you'll find out. I'm not giving it away.
Oh, good catch. I was seeing if I could catch you.
Water is going to help us dilute it. So for the second trial in the first procedure, we have to take 15 mils of acid and 5 mils of water.
Now, specifically, we're going to measure which one first, then?
The water first. I want you to go to 5 for the water, add it to the beaker, because we always add acid to water. A becomes before W in the alphabet,
Right.
Acid goes into the water. So then you're going to measure 15 mils of acid. The first trial you did 20 mils of pure concentrated acid. This time you're going to do 15 and 5 mils of water. So you've diluted it by 25% or so.
Sure. And it's key here now that we have 20 mils of solvent each time.
Total.
So now I'm not changing more than one parameter at a time.
Right, we're controlling the volume of the liquid that we're reacting
There
the
you go.
tablet with. So let's pretend we have our diluted acid in here, 5 mils of water, 15 mils of acid, tablet, boom. 1 Mississippi, 2 Mississippi, until it completes the reaction.
Excellent.
Record the value in your data chart.
There it is. Whoop. That's
Whoop.
it.
High, medium, low. Third trial on
Rinse
the
it.
first procedure. After you rinse. Whoop. A little couple extra drops of water ain't gonna hurt us. We're gonna dilute our acid by 50%.
So now it's going to be 10 mils of water, 10
and
mils
10
of
mils of
acid.
acid.
Beautiful.
Always start with the water. Measure the water out first. Oop, a little more. Put that in your beaker. Add 10 mils of acid on top. Swirl. Another third whole tablet on top. Time it. See how long it reacts. Then you're going to clean that one up.
So now we're good with concentration.
Concentration's out of the way, so you can move that beaker out the way. Then we've got to do particle size.
Okay.
That's where we are going to...
That sounds like surface area.
Yeah, surface area is particle size. Check that out. So you're going to need 3 tablets again, but this time you're going to react a whole tablet, a tablet that you broke up by finger pieces, and then a tablet that you ground up in the mortar and pestle. The way you do that, get your particle size beaker, put it on the table. You can start by putting a whole tablet in, and then you measure 10 mils of the concentrated acid on top.
Okay.
Dump it in, see how long it takes to react.
Okay.
Rinse it out. Start in the second procedure. Take that second tablet you got and break it up with your fingers. Okay? Break it up into pieces, you know.
So we want some chunks.
We want chunks. We do not want a powder yet.
Right. So
We'd like
4, 8
quarters
chunks.
Or eighths, maybe 16ths here. Okay?
Yeah, seriously, don't mess up your new nails.
These are the type of chunks we want. We don't want it much smaller than this, etc., etc., etc.
And personally, guys, just so you know, when you do this, can we do it right over the beaker so we don't lose it? See all that extra?
Yep.
I want it all. I want to get as much of it in there as you
in
can.
the beaker. In my
So I would
case,
break it up right over the beaker. That'll work too.
that's what Monaco did, but it's a little sloppy. How much acid are we going to add to this second trial?
Well, we added 10 mils to the first trial, so we should double it, right?
No, we want to keep it consistent because we need to control all the other things other than particle size. So I'm going to add 10 mils of the concentrated acid right on top. Count your Mississippis, use the timer, record in the data chart. I want to see particle size, whole tablet, chunks, powder, versus time it took for it to react.
Okay.
Is it fast, medium, or slow?
Okay.
Rinse down the drain, move your particle size stuff out.
We got one more. We got to grind it, yeah.
Oh, right, I forgot about that. Yeah, we forgot.
It's okay.
Particle size. So we got to do the grinder. Toss a whole tablet into the mortar and pestle, and you grind that sucker up. We want powder. Powder, 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 powder.
Yeah, a little crush and then a swirly swirl.
Then a swirl, crush and swirl, crush and swirl.
There it is. There's the swirl.
Okay. Now we got to get as much of this as we can into our beaker.
Right, because remember, guys, if we're doing a tablet each, we want there to be about the same amount. So just, don't break the thing, but get as much of it out of there as you
If you use a half a tablet, obviously it's going to react faster than a whole tablet. So you got to try and get it all in there. Nice powder. And to this powder, we're going to add how much mils of acid, Mr. Milks?
10 mils of acid, you said.
Not 20, because we got to have the acid consistent in this second procedure.
Yeah, the volume needs to stay the same of acid.
And the particle size changes.
There we go.
So, clean it up, down the drain, rinsey rinse, out it goes. You're ready to move on to the third and final procedure in this particular lab. You're going to change the temperature of the reactants. We got a hot water bath going here. If it's not boiling, that's okay. We just need to be able to compare room temperature to middle of the road to hot.
Okay. So what are we going to do here?
We are going to, again, use 3 tablets, but the 3 temperatures that we're going to do are room temperature concentrated acid, medium temperature concentrated acid, and hot concentrated acid. So the way you're going to do this, you're going to take 10 mils of acid. So the only procedure where you use more than 10 mils is the first procedure. All the other procedures today, you're going to only use 10 mils of acid and be consistent, okay? I'm showing you how to heat up or not heat up your acid. So here's my 10 mils of acid. I want this one to be the room temperature one. This has been sitting out all day, all night, all week. It's already at room temperature. What is room temperature? Put a thermometer in there and find out, okay? It's about, in this case, looks like 22, 23 degrees. My data chart would be temperature, 22, 23, whatever it is, versus how long it took for this tablet to react. Dump it. Once it's completely reacted, dump it down the drain, rinse with water. Next one, medium. How many mils of acid, Mr. Milks?
10.
10 mils of concentrated acid, do not dilute it, but we're going to put it into our hot water bath this time. We want it to be about middle of the road temperature. So if room temperature was 23, let's
We're talking
double it.
40 to 50.
45 to 50. Don't have to be accurate, exactly accurate, but take the thermometer out before you do the reaction, please. And notice, this happens very quickly. We had said, hey, put it in there for 2-3 minutes, but this stuff heats up so quick, you don't have to. So go to about 40, 50. There we are. At that point, I'd pull it out the bath, throw my second whole tablet in there, boom. Count how long it takes to react completely. Third and final trial in this lab, we got the hot reactants. How many mils of acid, Mr. Milks?
10 mils of acid.
Excellent. And
I'm going to be saying this in my sleep. 10 mils of acid.
We're going to get our thermometer in there, and we got to heat this sucker up. So if we doubled the temperature from 23 to about 45, 50.
I'm talking 80, 90.
80 or 90. I don't want it to boil because this stuff is an acid. It turns into a gas very quickly. You'll start to feel burning in your nosies. No, 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 no. We don't want that. So don't wait for it to boil in the test tube. Just wait for it to get to like 90-ish.
Yeah. You can even probably pull it out at 80. I bet the temperature's going to keep going up for another second.
For sure. And this one most definitely put it in the test tube rack, toss the tube, the tablet in there, and wait and see how long it takes to stop reacting, stop bubbling, and finish up.
So I noticed one thing that is the same for every one of these 9 trials.
What's that?
That the reaction is done when the bubbling stops.
Absolutely. That's how you know the reaction's completed.
Right. So
Period.
that's really what we're
End of
looking for.
story.
You're going to do it 9 times.
Total.
Yep. You get a baseline for each one and then change each one twice.
Right. And the conclusion part of the lab is mostly
here I
making
come.
relationship statements, okay? These are real rudimentary data charts.
wanna
Don't
see that
show them,
stuff.
Milks.
No, I turned the.
You got to
I turned
know
it-
how to do data charts.
I turned
guys.
I turned it myself.
The analysis is making some relationship statements, okay? So I want to know a relationship. As concentration of the reactants does blank,
Increase or decrease?
increase or decrease, the rate of the reaction does,
Increase or decrease?
and then we want to know why. Explain the data in terms of collision theory. So
Yo, that was right in your bell work, guys. Come on.
for sure.
But I want to talk. I want to see something
relationship
about
statements. Boom, boom.
collision theory. Are their collisions good? Increasing, decreasing? Why?
Boom. Are they more effective or less effective?
Why?
Why? Okay.
Okay.
Now, the number 4 and 5 are fun. Considering the 3 tests you just ran, describe the conditions for the fastest possible reaction.
Cool.
We're not going to test this one, just hypothesize it.
Okay.
And then the opposite's true, the slowest possible reaction.
Cool.
CEI as always.
CEI. Let's do that.
Restate our purpose of our lab. Look at that in the background. Make a claim. Pick one of the ways you made the reaction rate change and make a claim. I can change the rate of reaction by...
What did you actually do?
Did you speed it up? Did you slow it down?
No,
How'd you do
no,
it?
you didn't speed it up or slow it down. You changed concentration. You changed surface area. You changed
Right. I
temperature.
can change the rate of a reaction, meaning speeding it up or slowing
Right,
it down,
by-
by changing concentration.
Right.
temperature,
All right.
Data and everything. My data shows that when I pick one of your data sets, okay, maybe you loved the concentration one. That when I increased or decreased the concentration of acid,
This
this happens.
Yep.
Interpretation. Explain how the ideas in collision theory and effective collisions support your claim and data. Collision theory states the 3 parts of collision theory. Say them over again. Go back to your notes and write them out again. And then relate those 3 ideas to why your reaction sped up or slowed down and use the word effective collisions.
Beautiful.
Thanks, everybody.
See you guys.